Right, we're down here in the workshop to do the practical checks that are really the key parts of this module on service and repair charging systems. We're going to be using three important pieces of equipment to do our checks. Now those checks are the voltage regulator setting on the vehicle, the maximum current output of the alternator, and then we're going to check the system's condition, the wiring's condition, and we're going to do voltage drop checks on the wiring within the system while it's operating. Now our test equipment is a current clamp. This senses the current coming out of the main output of the alternator, and we've just conveniently extended that so you can see it. We've got a digital multimeter, and this is going to be used to confirm the voltage available at the battery, and then in later checks to check for any voltage drop very accurately along our wiring lines. In the case of us needing an additional load because the standard loads on the vehicle aren't enough, we're able to add anything up to 70 amps of additional load with this lamp bank. We've prepared the vehicle. We've prepared it with guard covers, and we've done a thorough vehicle inspection to make sure that the alternator terminals are clean and tight, the belt is firm, and it's securely mounted. So we've eliminated as many of the simple problems as possible. The vehicle does have an extraction system on it, and we know that the battery is fully charged. So let's get started, and we'll do the first of the checks, and that's going to be our voltage regulator test. Now, the voltage regulator test is going to establish the voltage at which the regulator is operating. Now, all of our tests are going to be done at the same engine speed. If we were working on a truck, we'd be in the 1500 rev range as a maximum speed. At that speed, the alternator would be travelling fast enough through ratio to get maximum output. We're currently here on a car, and so that's going to have a ceiling set of revs around 2000 revs, because the pulley ratio gives us a high enough alternator speed at 2000 revs to give us maximum output. If we were doing this on a motorcycle or a light engine, we might have to go as high as 5000 revs to get to the same figures. Now, we're going to start the engine and run it, but we're not going to add any additional load. We know this alternator has got quite a high output, but we want to see that it will keep the voltage at a stable level when it's under light load, but at reasonably high speed. So we're going to start the car now, and let's look at the numbers that we get on our meters. Immediately, the alternator is producing around about 20 amps. And I can see quite clearly on my digital multimeter, I've got 14.5 volts. Now, with the engine speed at around about 2000 revs, we're able to establish that the regulator is doing its job. So Rick's just going to bring the engine speed up for me. We'll confirm that at low load, high speed, we can see that the regulator is keeping this alternator voltage down to a nice, safe level. We're nowhere near its maximum potential, and so the regulator is doing its job. Now we'll conduct the maximum output test. This is going to entail reading the current, so the current clamp hasn't changed, and reading the voltage, and we haven't moved the voltmeter either. What we will be doing is adding additional load. So we'll start the car, and then we're going to turn on the headlights and the blower fans and the air conditioning. And immediately we've brought our charging output up to around about 80 amps. So we go to our 2000 revs, let's increase our load. And here we are, we're at 134 amps at 13.9 volts. We've clearly met our minimum of 120 amp output, and we've still got enough voltage to be charging the battery. So we'll back the load off. We only leave it on for about 15 seconds maximum. And we can turn off our accessories, and we've successfully completed the second of our tests. So now we've established that the voltage under light load is safely kept at 14.5 volts, that under maximum demand the alternator will produce 120 amps and still maintain 13.8 volts, so it's managing to continuously charge the battery and meet all the loads. So now we do a simple calculation. we divide our maximum output current in half and use that as a figure to do our circuit condition test or our voltage drop test. Now, conveniently, turning on the headlights and turning on the blower fans and the air conditioner will generally give you about half the rated current. So even if you don't have any special equipment, you can do this test simply using the vehicle. So what we're going to be doing is we're going to suggest this can be done in one of two ways. In a small vehicle like this, where the battery and the alternator are conveniently located, we can do what we would call a direct test. And so we would take our positive lead and place it on the positive terminal on the alternator. And we would take our negative lead and we move that to the positive terminal. That's because the alternator is more positive than the battery, it's feeding the battery. And at half the rated current, we'd be looking for no more than a combined total in the whole system of half a volt. So we're going to see what reading we get on our digital meter. It's going to automatically range for us, so let's see what we've got. So we'll just put on all our lights. It's told us we're at nearly 80 amps with that load, probably a little bit higher than normal, but that's okay. We're only seeing 0.2 of a volt drop on the positive cable. So while that load's still applied, we'll swap our leads around and we'll check on the negative side. And again, with the same load applied, about 80 amps, on the negative side we've got 0.05 of a volt drop. We've got very, very low voltage drop. And we're measuring right from the battery terminals. So we're considering even the voltage drop from your battery clamps. We've measured that directly, and that's convenient. Where the battery and the alternator are a fair distance apart, what we would simply do is measure the alternator output voltage, and in this case it's 14.28 volts, and I would compare that to the voltage getting to the battery. 14 volts. So we've got 0.28 of a volt drop loss. That's quite acceptable. We're allowed to have about a half a volt drop. So in this way, we've done the three tests that thoroughly check the charging system on a vehicle. We've checked the voltage regulator setting, we've checked the alternator's maximum output, and we've checked the condition of the wiring by doing a voltage drop test at half the engine's load. So we've successfully tested this system, and we know that it's fine to go back into service. Okay, so let's summarise what we've done. We've checked the voltage regulator setting. We've done that at high speed, light load. So we had no additional load turned on. We wanted to see that the regulator could keep this alternator down to a safe voltage and current output under high speed, light load conditions. The second test we did was to establish how much output has this alternator got. And so we increased the load simply by turning on the lights and one of the main consumers, the air conditioning system. That took us up to just over half the output of the alternator that we predicted, so we added an additional load. We were able to confirm this alternator, rated at 120 amps, was putting out somewhere over 130 amps, whilst the voltage was maintained at about 13.8 volts. Quite enough to keep charging the battery. So we were able to establish that the alternator's output side was fine. The third component we need to test is actually the wiring. And so we did that by doing some voltage drop tests. And we offered it in two ways. Where the battery and the alternator are conveniently located, we simply measure from alternator positive to the battery positive terminal, and we got a value, and it was about 0.23 of a volt. Quite a low value, which we'd hoped to get. We then repeated the tests on the earth side, just in case there's problems with earth straps or connections, and we were able to establish on this vehicle it was 0.05 of a volt, virtually zero. In this way, we directly measured that there was no problems with the voltage drop. Where that's not possible, where the batteries and the alternator are some distance apart, like on heavy vehicles, you can simply measure the voltage at the alternator, and without changing the conditions, that is at half the rated current, we then repeat the test at the battery, at same half rated maximum current, and we do a little sum to work out the difference between the alternator voltage and the battery voltage. If it's within half a volt, we have no problems. So these are the tests that you'll need to do and to be able to perform to do an alternator service and test repair.